This is AWR Microwave Office tutorial series. In the previous video, we talked about what is the effect of change in dielectric height as well as width on the microstrip transmission line. In this video, we'll discuss what if we'll change the dielectric constant value, because the dielectric constant value determines the impedance of the transmission line as well as the length which should be matched with the calculated impedance. So we'll see how dielectric constant affects impedance as well as the length of the transmission line. So let's get started. In the first step of this video, we are going to run AWR design environment and we're going to open the previously created project which you can download using the link given in the description. To open that, we'll go to File, click on Open Project. Just locate the file which you have downloaded. In my case, it is saved on desktop. So I'll go there, select the microstrip _ imp.emp file and click over Open button. So in previous video, we have made this schematic where we have defined the substrate. Here we are running the sweep variable for the substrate height, and this is the schematic of a transmission line connected to a 50 ohm port, and other side is just connected to ground, or you can say it's shorted. Before moving further, let's understand that like previous simulation, we can't directly sweep the dielectric values like width and substrate height, because the line length is the function of dielectric constant as well. So as you can see these equations on your screen, so here we have to calculate the effective dielectric constant for the microstrip line, and the length of the transmission line is 1/8 of wavelength. So if we'll calculate the wavelength, it is the function of the speed of signal. Alright, so from these equations we can see the speed of signal is 0.533 multiplied by light speed. So here if we'll change the dielectric constant value, it will change the effective dielectric constant as well as the speed of signal, and which will change the length of the transmission line. So we are going to add all these equations in AWR, and based on that we are going to sweep the dielectric constant value. So first we are going to assign the variables to the transmission line. So I'm going to delete this one here, and let's make this HMM. So this will be small h. We are going to change the dielectric constant from 4.7 to make it a variable. Let's make it ER. Alright, so this is now the effective dielectric constant. We are going to calculate that in the next section of this video. So make this ER as well. And apart from that, we are going to set the width of the transmission line. Let's make it small w, and the length will be L. Alright, so here you can see all these highlighted variables which we need to define. Now to define these variables, we are going to add couple of equations which we can add here. So to do that, we'll just click over this x is equal to y equation from the toolbar, and let's define the default value of ER is equal to 4.7. So now you can see the error have been gone from here. Similarly, we are going to define the variables for width, which was 2.9. So let's make small w is equal to 2.9. Height of the substrate will be 1.6. So let's define that as well. And now length we are going to calculate based on the dielectric constant value. So that will be a variable which will sweep here. Alright, so till here we have defined all the equations. As you can see on this image, we have entered all these equations in the substrate, in our transmission line, as well as we have defined the variables and equations. And we are going to sweep it between 2 to 6. So let's start value will be 2, stop value will be 6, and let's make it step size to 0.1. Here we go. Now we'll again go back to our plot. We are going to modify the measurements. To do that, we'll go here. Okay, so we're going to plot for fixed frequencies. We are going to use x-axis for sweep variable, and y-axis will be for impedance, and we'll just click over OK and run the analysis. Alright, so as you can see, as we are changing the dielectric constant value, the impedance is going low. Now why is that? Because the capacitive coupling is directly proportional to ER, right? So as we are increasing the ER, the capacitive coupling is increasing, all right? And that means, and capacitive coupling is inversely proportional to the impedance of the transmission line, right? So as we are increasing the capacitive coupling, the impedance is going low, all right? Yeah, next we are going to save the project. To do that, we'll go to File, click over Save Project. For more tutorials, visit us at resources.emaeda.com and don't forget to like and subscribe our YouTube channel.